All right. So, guys, notes our first day notes here. Just in general, okay. If I find it important enough to write up on the board, you should be writing it on your paper. Okay, just in general. Now, not everything that I write up, if I'm just scratching something off to the side, you don't necessarily need to write that. You need to get in the habit of determining what is important and what isn't. Okay. Now, keep in mind what notes are for. Your notes that you're taking today are not just for today. They're not just, will I remember this for tonight's homework? Okay. The notes that you're taking today are going to help you study for the test in a couple weeks. They're going to help you in January when we have to still remember this stuff for the midterm. And in June when we still need to remember this stuff for the final. So it's not just, yeah, I'll remember that. I don't need to write it down. It's, will I still remember that in 5 to 6 months? Right? And if the answer is no, then let's write it down. So even if it seems common sense, you're like, yeah, I got it, no problem. Just write it down, right? It's better to have more notes than not enough notes in general. Okay? All right, so today, what we're doing, you can see off on the side our I can statement over there, over the codes, and it says I can write and solve one-step equations. We're doing basic one-step equations today. I know that you're going to know the answers. Okay, that's not what it's about. Okay, I know you know how to solve. What today's about is, can we show our work correctly? And do we know why we can do certain things? Okay. And so yes, when I give you the problem, x plus 4 is equal to 10, I know you know the answer to that. Okay, don't get me wrong. I know that you can look at that and say the answer is 6. I know. Okay. But what we're going to do is we are going to talk about how are we going to show work, how are we going to do this. And yes, we are going to show work on the basic easy problems because real soon it's going to get a lot harder. Okay, we're going to get longer problems, more difficult problems where we have to keep track of what's still there, what's gone, all. So we're going to talk about how do we show that, what does it look like, all. Okay. So we have x plus 4 is equal to 10. This is our first example problem. X plus 4 is equal to 10. What would I do to solve this? Again, not the answer. We know the answer is 6. What do I do to solve this? Is it
10 minus 4.
10 minus 4. So where that 10 minus 4 comes in is we're trying to get rid of anything that's attached to the variable. Right? The whole goal is to get the variable by itself. Right? X is equal to something. So if you have something that's attached to the variable, we're going to do the opposite of that. We have plus 4, we're going to subtract 4. And we are going to do it on both sides. Whatever you do to one side, yeah, do the other. So we have plus 4 attached to the x. We're going to subtract 4 to get rid of it. I'm going to cross it off. I'm going to draw a line through that showing that the plus 4 and the minus 4 cancel each other out. And all I'm left with on that left side is an x. And then this is where Isaiah said 10 minus 4, and we get our answer. Okay. This right here, guys, this is the work that we should be showing. Okay. This is the work that we should be showing every time we see a problem. Whether it's a 1-step problem, a 5-step problem, whatever it is, this is the type of work we're showing. Where we work straight down. Okay, we're not working off to the side. We're going straight down. We're canceling stuff out to get our answer. You want to circle your answer, that's fine, whatever. Some people like to draw a line right here, that's fine. Okay. Now, the reason why we can do this, the reason why it works, we got to give a name to it. Okay, this step right here where we subtracted 4 from both sides. The reason we can do that is called the subtraction property of equality. Subtraction property of equality. That is the mathematical property that says I can take 2 things that are equal and I can subtract the same amount from both of them and they will remain equal. And that's all we're doing. We're taking 2 things that are equal, we're subtracting the same amount from both sides and they remain equal. That is the subtraction property of equality. Why don't you go ahead and solve that? Show the work how you think we're going to show the work, get an answer, and then we'll talk a little bit about it. Okay, raise your hand and tell me, what did we do to both sides? What's our one step that we do to solve this? Okay. Added 3 both sides, right? Added 3 both sides, cross it off, draw the line. If you want to draw the line, you don't have to. I do sometimes for some reason, I don't know why. There we go. Good. Somebody raise your hand and tell me, what is this property called? Why can we do this? Why can we solve the problem this way? What's it called, Bishop?
The addition property.
Perfect. That is the addition property of equality. Bishop, why is it the addition property, not subtraction property? There you go. We're adding to both sides. So whatever we're doing to both sides, that's the name of the property. If we're adding on both sides, it's the addition property of equality. We can add the same thing to both sides. Great. Double check your work. Did you work straight down? Okay, there should be 3 lines worth of work there. The original problem, +3 + 3, and your answer. Okay, we should not be working off to the side. Work straight down, otherwise we're going to start getting confused when it gets more difficult. Okay, any questions on these 2? Great. Let's go. Let's practice that a couple times. Real quick, nice and easy. Let's go. All right, there's 3 of them. Show your work, get your answer. And we'll talk about it. This guy's pinching up. They get 3 volunteers to write up some work and answers to. Bishop, which one?
I'll go with -3.
The middle one? Okay. Sam, which one?
The far right one.
Far right one? Great. And as they're writing that up, you turn somebody around you, see if they got the same thing. See if they got the same answers you do. And if they didn't, talk about why. All right, here we go. Here we go. Let's take a look. So I'm going to start on the right, work my way that way. Here we've got a positive 1.2. So we are subtracting 1.2. We end up with 0.9. That's 1 point's kind of high. 0.9. There we go. We got 0.9 as our answer. Good. For here, we've got a -3. Okay, so even though this is a plus sign, even though this is an addition sign in the middle, you're not subtracting it. This is a -3 that's attached to the x. To get rid of a -3, we're going to add 3. So I add 3 to both sides to get that 15. Good. Very good. The only change I would make on both these is I would cross those out, just to show, yep, we got rid of it. Okay. Good. Now we come over here. The original problem, if you recall, was x minus 14 is equal to 43. Okay, I see this all the time because this has been drilled into your head at Nichols. It's been drilled into your head. You see minus, you change it to plus and negative. We don't need to do that. Okay, we don't need to do that. You change it to plus and negative, and then you added the 14. Can't we just look at this and say that's a -14? Yeah. We got to start doing it. Okay. This is fine. It's just extra work. It's 2 extra pencil strokes that you don't need to do. We see minus 14, that's a -14. So I do the opposite. I add 14. Okay. So it's fine if you're doing that now. I'm going to push you to change your thinking and just think of that as a -14, -14, and we can go straight off that. Either way, here we're getting 57 as an answer. Perfect. Good. Good. Questions on that? All right, let's move on. X equals 16. If there is no symbol in between a number and a variable, what operation is it? Multiplication. So it's multiplication here. Side note, don't use X as a multiplication symbol anymore. Okay? So if you're going to do multiplication, don't say 4 times something. Okay, not with the X. Because that X is a variable now. Okay? So if you're going to do multiplication, 4 times 3, either put the dot there, put it in parentheses, something like that, but don't use an X. Okay, it'll get confusing. All right, so we've got 4 times X equals 16. Remember, what are we going to do to solve this? There you go. We're going to divide by 4 on both sides. And I'm not going to use the division symbol. What am I going to use instead? Slash. Yeah, I'm going to use that fraction bar. I'm going to use that bar. Right? I'm not going to use that division symbol because this is going to help us to get our exact answers that we need. Now, here we know it's 16 divided by 4 is 4. We get our answer. Well, what happens if it's 3x is equal to 2? Then I want an exact answer. Instead of doing divide by 3, and then having to grab our calculator and get a weird repeating decimal, if I just write that in with that fraction bar, what's my answer? 2/3. The answer's right there, right? So if you use that fraction bar instead of division, the answer's there, right? Your fraction is just there in your work. It's a little less work, a little easier. Okay. So we're going to use that division, that bar instead of a division sign. Okay. What property name is this?
Division property of the.
Which one? Division or multiplication? Division, because we are dividing both sides, right? So this is the division property of equality. Whatever we are doing to both sides, that is the property. division property of equality there. We got one left. Which property do you think it's gonna be? Multiplication property of equality. We got it. All right. So that's gonna look like this. All right, let's say we have something like that. All right, where we have division in the problem already, we need to get rid of it. We've got x over -4. Remember that fraction is just a division problem. So that's x divided by -4. And to get rid of division, we multiply both sides. What am I going to multiply both sides by? -4. Got to take that negative with it, right? So I'm going to multiply both sides by that -4. Okay. This is the one time, guys, that I don't strictly work straight down. Why do you think I might not do times 4 times 4? Why do you think? Because I've seen some mistakes being made here. What mistake do you think people have made? Cooper?
You had to carry over the negative.
Okay, first of all, we've got the negative. Okay. What else might people do? Maybe you don't do it, but might somebody do? I've seen people do this. -4 times -4 is 16. Right? Because you've got a number times a number right there, and it just looks like we're supposed to multiply those. Now, you guys are smart, you're not going to do that. I know, but just to keep things clear, I like to write it out here. Because what we're doing is we're multiplying that entire thing by -4. I'm taking this entire thing times -4. That x divided by -4 times -4. Those two things are going to cancel out. Now I've got 10 times -4 is -4. Okay, so this is the one time that I kind of write the multiplication off to the side. And then I put my answer. Just slightly different. And then just because we need to have it in our notes, this is the multiplication, like we said, property of equality. Questions on those before we do some practice here? Great. While I write these up, tell the person next to you, how do we know what property of equality we are using?
Sure. I was listening, so.
Okay, there are two. That second one's different. So I'm challenging you here to remember what to do. I want you to do both of these without a calculator. No calculator. Hopeful that you'll at least get the first one right. Second one, if you're unsure, try something. somebody around you to talk to, especially that second one. What do you think we can do there? Okay.
So I remember from last year. What'd you get? I got 20 points. I haven't even finished. Yeah, I think that's one too. I think you just said the next thing. But I feel like I did.
Okay, here we go. Raise your hand, tell me, what are we doing on both sides for this first one? Dividing, right? Because there's no symbol in between, it's multiplication. Common mistake, what do you think the common mistake is? Well, that, but what else, Cooper?
Said like taking it times the negative 2 by negative 3.
You could see that. I want to show you what I see more than anything else on this problem. Is people seeing negative, and they're like, oh, I got a -3, I'm gonna add 3. Right? That's not it, right? We know that, we're better than that. So we know that that's multiplication, so we are going to divide by -3. Divide by -3. You gotta take that negative with it. What is 15 divided by -3? -5. Make sure you got a negative on that. Positive divided by negative is a negative, right? So -5 for that answer. And remember, we can check our answers. We can plug that back in. -3 times -5 should equal a positive 15. It does. All right, now this is the tricky one. That is probably one of the trickier questions of the day, right here. 2/3 times x is equal to 14. Now, what I saw a lot of us doing is you said, all right, I got multiplication, so I'm going to divide. I don't know about you, but without a calculator, if I just look at 14 divided by 2/3, that doesn't really make a whole lot of sense. Okay. So we don't want a tower of fractions here. I don't want fractions inside of fractions. So what can I do instead of dividing by 2/3? Okay. Okay, if I do that, that's going to be 0.6 repeated. Not super easy to divide by, right? Good idea. Okay, yeah. So what did you end up multiplying by? Yeah, so what we're going to end up doing here is we're going to multiply by what's called the reciprocal. We're multiplying by the reciprocal. And this is that keep change flip. Right? So instead of 14 divided by 2/3, we're going to do 14 times 3/2. Because multiplication with fractions is a whole lot easier than division. So whenever you see a fraction, whenever you have a fraction attached to a variable, you are going to multiply by the reciprocal right away. We don't even have to write out the division. Just multiply by that reciprocal right away. And whatever I do to one side, I do to the other. You know, those are going to cancel out, and we're going to get an answer. Everybody understand what we did with that reciprocal? Multiplying by that reciprocal on both sides. Okay. Now, when we go to do 14 times 3/2, I don't need to do 14 times 3. How can I simplify this so that I don't have to know what 14 times 3 is? Cooper?
Do 14 and yeah, divided by 2 and then
Yeah.
47.
I can simplify these, right? I got a 14 on top and 2 on bottom. That's the same thing as 7 and 1. Now it's just 7 times 3, and we all know that. Get 21, right? So if we're doing things the right way, which is multiplying by that reciprocal, simplifying when we can, we don't need a calculator to do problems like this. Okay? So we shouldn't just grab our calculator and say 14 divided by 2/3. We should be able to rewrite it with the reciprocal, simplify, and get an answer. Again, that's probably the toughest problem that we're going to see. Just knowing and remembering what to do. Any questions about that? Hey, what would the reciprocal be of this? 4/5 times x? 5/4. So we multiply both sides by 5/4. And then depending on what's on the other side, right? If I had like a 16 there and I got 5/4, then yeah, I simplify here. Right? Okay. Couple more questions and then we're done. And then we'll talk about how to do homework, expectations on homework, that sort of thing. Let's go.
Can we use our calculators?
No calculator.
I'm not
I'm gonna give you 10 seconds to talk to the person next to you. What do you think the answer is? Okay, here we go. Here we go. Hey, we don't need to know what pi represents. Pi is just a number. Okay? And I know some of you guys know long digits, whatever. Pi is just a number. So if if I'm adding 3 pi, I can just subtract 3 pi. And so 7 pi minus 3 pi, how many pi's do I have left? 4 pi. That's it. 4 pi. Okay. So if you see a pi in your problem tonight, please do not change it into 3.14. Don't use the pi key. Just do this. Okay? Just combine. All right. Hey, one more here that we want to look at is a word problem, because we are going to see something like this in the homework. So we ought to know what we're doing. What they're going to ask you to do here is they're going to ask you to create an equation. Okay? You have to create an equation. And anytime they want us to create an equation, the equation that we make, first of all, what's the difference between an equation and an expression? Raise your hand. What's the difference between an equation and an expression? Allie? There you go. An equation has an equal sign, and an expression does not. Okay? So if they want an equation, that means we want an equal sign. Okay? When we create an equation, our equation has to be something that we can solve, which means our variable needs to be attached to a number, just like all the problems we've seen so far. So our equation that we create is not going to be x is equal to something plus something. That's not an equation for this problem. Okay? The equation for the problem is going to have that variable somewhere where we have to add or subtract to get there. So using the fact that we have the $12.95, the original price is the letter P, and then our discounted price in the picture says it's 44. Somebody around you, I want you to create an equation that's going to help us solve this problem. I don't care about the answer, I just want the equation.
Oh wait, I You didn't see that. Oh, you're trying to find out.
So, you know, at the end, it's gonna equal this kind of price. It's gonna equal 44.
Oh.
And then, I don't know, because this is just get a price.
Oh.
And then we know the original price is P, and we're getting 12.95. We're getting off Or just in general, saying.
Yeah.
Okay, here we go,
I didn't
here we
realize
go.
that 44 meant 23rd.
Raise your hand, tell me what equation did you guys come up with? Okay. What equation? One? How many people got this equation? Okay. How many people got a different equation? What other equation did you come up with?
We did 12.95 plus p.
Okay. Might have anything different, is it?
44 plus 12.95 is.
Okay. Anything else? Okay, so I don't want the variable by itself right away. Okay, so we're not gonna do that. Okay, so it's really between these. And so we need to think about what this is actually saying. What is our sentence, our mathematical sentence saying? If P is the original price, this is saying I'm taking the original price and adding $12.95 to get my discounted price. This one's saying I'm taking my original price, I'm taking away $12.95 to get that discounted price. Somebody raise your hand and tell me which one is going to make more sense to your logic, right?
The minus 12.95.
Yeah, because we have the original, we're taking away to get a discounted price, right? So this is the one we're looking at, right there. And again, we want the variable to be with it, to be in the equation so we can solve it. Now, when we go to solve it, we're going to add 12.95. This is going to give us the same answer, right? It's going to give us the same answer. But we need to write our equation like this so we can actually solve it. Plus, in big ideas, they're going to have the equal 44 there for you, and you got to type in the left side. So we'll give you that option. Okay. So we got to be able to create that equation, and don't just write the equation, but think about, does it make sense in this problem? Okay. All right. Any questions right now on 1.1?